excitement is in the air as NASA makes a game-changing announcement. For decades, people have dreamed of venturing further into space and exploring new frontiers. But the harsh reality is that space travel is challenging, dangerous, and time-consuming. However, NASA has a solution that will revolutionize space exploration and make it faster, safer, and more sustainable. They have announced a new technology called the nuclear thermal rocket engine, and it's nothing short of revolutionary. In this video, I will explain how the nuclear thermal rocket engine works and why it's such a significant development in space travel. So buckle up, grab a pen and paper, and get ready to be amazed by this exciting breakthrough in space exploration.
I'm pleased to announce that the nation's next big development in space technology is a major investment in getting to Mars. NASA will partner with our longtime partner, DARPA, to develop and demonstrate advanced nuclear thermal propulsion, a revolutionary technology that will allow the United States to expand the possibilities for future human spaceflight missions.
The story of nuclear technology in space exploration begins in the early days of the space age. NASA and other space agencies have long considered proposals for using nuclear energy in space missions. Two categories of these proposals emerged: nuclear thermal and nuclear electric propulsion, NTP-NEP. NTP involves heating deuterium or tritium propellant to create plasma, which is then channeled through nozzles to generate thrust. EEP, on the other hand, uses a reactor to power a Hall-effect thruster, ionizing inert gas like xenon, and accelerating it to generate thrust, while NEP offers a higher specific impulse or longer periods of thrust. NTP delivers greater thrust.
Our goal is to launch and demonstrate a successful nuclear thermal engine as soon as 2027. The idea of nuclear thermal propulsion is not new to NASA or to many. A half-century ago, the United States conducted its last nuclear thermal engine test under NASA's Nuclear Engine for Rocket Vehicle Application and rover projects.
One of the earliest efforts in this area was the Nuclear Engine for Rocket Vehicle Application, or NERVA, which was tested successfully in 1964 and 1969. Since then, radioisotope thermoelectric generators, or RTGs, have been used in space, powering missions like the Viking, Voyager, Galileo, Cassini, and New Horizons, as well as the Curiosity and Perseverance rovers. More recently, NASA, Department of Energy, or DOE, and commercial industrial partners have stepped up their efforts to realize the potential of nuclear technologies for multiple mission profiles. One of the initiatives is NASA's Fission surface power project, which expands on its kilopower reactor using Stirling technology, or Krusty project, to develop nuclear reactors that could power long-duration missions on the Moon, Mars, and beyond. In June, NASA and the DOE awarded 3 commercial design efforts to develop nuclear power plant concepts that could be used on the surface of the Moon and later Mars. This year, the NASA Innovative Advanced Concepts, or NAC program, awarded phase contracts to several proposed nuclear technologies. These include a hybrid fusion fast fission reactor that would power a mission to Europa, a nuclear thermal engine that could allow for missions to Mars in just 45 days, and a miniature nuclear battery that could enable CubeSat missions to the outer solar system.
Conventional chemical propulsion is not the most efficient way for our astronauts to do a deep space mission. Nuclear thermal propulsion is much more powerful, with 2 to 5 times the efficiency of chemical propulsion. And with the help of this propulsion system. Astronauts will be able to journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars.
Having faster and more efficient transportation technology is crucial for crewed missions to Mars, as traveling to the Red Planet using conventional rockets would take 6 to 9 months, and the missions can only launch every 26 months during a Mars opposition. During these transits, astronauts would be exposed to elevated levels of solar and cosmic radiation, and would spend the entire period in microgravity, which takes a serious toll on human physiology. A more powerful propulsion system would enable larger spacecraft that could accommodate larger scientific payloads and provide more power for instrumentation and communication. Several proposals for NTP systems have been made in recent years that could reduce transit times to Mars to less than 100 days, with some as short as 45 days. This would not only reduce the exposure of astronauts to the dangers of space travel, but would also allow for larger, more capable missions to be sent to Mars and beyond. As NASA and its partners continue to explore the potential of nuclear technologies for space exploration, the possibilities for new and exciting missions continue to grow. Whether it's developing new reactors to power long-duration missions, or using hybrid fusion/fast fission reactors to explore the far reaches of our solar system, the future of space exploration is looking increasingly bright and promising.
Expanding our partnership with DARPA and its Draco program will help, and it will help us create a new era of space transportation. One small step is one giant leap for humankind. And this partnership will take us one step closer as we dare to explore the unknown. Let us dare to ignite the future farther, faster, together.
With these advanced concepts, we're pushing the boundaries of what's possible and opening new frontiers in space exploration. In conclusion, the nuclear thermal rocket engine is a technology that has the potential to revolutionize space travel and make it faster, safer, and more sustainable. The future looks bright, and the possibilities are endless. NASA and its partners are dedicated to making this technology a reality and pushing the boundaries of space exploration. Thank you for watching and for your ongoing support. We hope you found this video informative and exciting. Please share it with your family and friends, and let's spread the word about this revolutionary technology.